Good morning, sir.
Good morning, Nana.
Sir, what is the syllabus for this week, sir?
This weekend syllabus, no exam.
Why, sir?
This weekend, mostly there is no exam. Okay, na? And next
Okay.
exam will be there on November 2nd on the total cumulative. Okay,
Sir,
na?
this week
From
exam is there.
May 2, sir. From May syllabus.
The total syllabus which you have so far covered under atomic structure, periodic table, chemical bonding, stoichiometry.
Hello, sir.
Hello?
Okay, sir.
Sir, they have said that they will conduct exam on 21st and 22nd, sir.
Who
22nd
said?
JEE Main.
Who said?
In the official
Who
group,
said
they have
that?
sent us message, sir.
I don't know. I am sorry. That is otherwise. Official group, what they send?
They have sent the syllabus and about the syllabus they have given that 21st is your CDF exam and
Show me
20.
that. Once show me that.
Just a minute, sir. I will send you, sir.
You send me?
Yes, sir. I will send you, sir.
Yeah.
Okay, sir.
And up to the Lewis dot structure for us.
Okay, sir.
Okay. Now you see everybody. Now I am going to discuss about the Lewis dot structures. Already we discussed about the octet rule. So what is the octet rule? The ability of atom and then the tendency of atom. Tendency of atoms, okay, to achieve 8 electrons, to achieve 8 electron in their outermost shell, in their outermost shell is known as Lewis octet rule. Is it correct? The tendency of atom to achieve 8 electron in their outermost shell. In that point, while achieving 8 electrons, atom may lose the electron, that is, may transfer the electron, or may share the electron. Yes or no? Transferring leads to ionic bond, sharing leads to covalent and coordinative covalent. Already I have discussed about this. Yes or no? Who will form ionic bond? Those atoms, electronegativity difference is large. Electronegativity difference is large. They will form ionic bond. Electronegativity difference low, they form covalent bond. Electronegativity difference very low, they forms a metallic bond. Already I discussed about the points. Okay, those which have electronegativity difference large, like example, what is that? NaCl, like example, HCl, like sodium atom. Yes or no? Sodium atom loses one electron, chlorine gains one electron. Why do that sodium lose one electron? Okay, why do that sodium lose one electron? Because if you look at the structure, sodium 1s2, 2s2, 2p6, 3s1, it has one electron in their outermost orbit. What is out the chlorine? What is that? 1s2, 2s2, 2p6, 3s2, 3p5, 5 electrons in their outermost orbit. Some students are getting doubt, sir, if it gains one electron sodium, automatically it like helium, sir. No, sir, the duplet configuration only applicable for duplet configuration, only applicable for note, only applicable, okay, when one energy, when only one energy shell is present, only one energy level is present. One energy level means one s orbital only present. Okay, then only duplet configuration is applicable for as a stable. So here three energy levels are there, no duplet configuration, so should be octet configuration. To get octet, it should lose one electron, it become Na plus. To get octet, it should gain one electron, it becomes Cl minus. That is why they form ionic bond. What about hydrogen? Their electronegativity difference 2.1, 3.0. Difference is less than 1.9. Therefore, covalent bond. Difference of electronegativity less than 1.9, covalent. Greater than 1.9, ionic. This is 0.9. This is 3.0. Difference is less greater than 1.9. That's why they form ionic bond. Now, hydrogen as 1 valence electron, chlorine as 7 valence electron. But hydrogen gives 1 electron, chlorine gives 1 electron, both shares form HCl, covalent bond. What about the sodium? Sodium, both are low electronegative, neither give electron nor give what is that? Take electron. That is why it form metallic bond. We will discuss about that in later. So this is about the minimum concept about the ionic bond and covalent bond. Sir, I will discuss in depth after coming back from the home, because the self schedule, ionic bond 5 days, covalent bond totally 5 days, like that will be there. Don't worry. But just introduction only this. Now you go for Lewis dot structures. Okay, na? Somebody having the doubts? Tell me, Sai Vignesh. Sai Vignesh.
I have mistakenly raised it, sir.
Sir, funny.
Sir, you said that duplet configuration is only for one energy level, sir.
Yes, one energy level.
So for lithium, beryllium, they also go for octet configuration.
Oh, na. Why? Okay. Lithium. You said lithium. What is the lithium?
1s2, 2s1.
1s2, 2s1. Yes or no? Now,
Yes.
lithium loses how many electron?
1 electron.
It become what is that?
Li plus.
Then what is that?
1s2.
One energy level is there, more than one energy level is there now.
Oh, okay, sir, I understood.
Understood now?
Yes, sir.
Sir,
Yes,
once
good
can
boy.
you tell,
Cheppandi. Bol.
sir, once can you tell coordinate covalent bond?
No, I don't want to, because it is not required now. Sir, whatever is for your convenience. If A atom give 1 electron, B atom give 1 electron, both shares. That is called covalent.
Yes, sir.
A atom only given 2 electron, B atom nothing, but both shares. Then that is called coordinative covalent.
Okay, sir.
Understood the difference?
Say,
A and B both give one electron, they shares covalent. A only give pair, but B does not, but both shares. That is called coordinative covalent.
okay, sir. Thank you, sir.
Dinesh Kumar. Dinesh Kumar. So those who don't have the doubts, sir, when we college start, I don't have an idea. Ratnashekar Prasad.
Sir, even hydrogen attain duplet configurations,
Yes, 100%.
but it will
That
share
is
the
one energy
electrons,
level
no,
only
sir?
present. 1s2 or
Yes,
1s.
Okay.
Dinesh Kumar. Dinesh Kumar. Okay. Anyway, so these are your doubts, I think, clarified. Now I will go for my class. That is Lewis dot structures. We have explained the molecule also. Lewis dot structures
Hello, sir.
are.
Sir, when HCl is added in water means H plus and Cl minus do not form, sir.
What is that, sir? What is that?
If HCl added to water, sir,
Ah,
then H plus and Cl minus won't, sir.
sir, your voice is beeping, sir. Tell me.
Sir, if HCl,
Ah,
sir,
SCL, yes.
is added to water,
Yes, okay.
then H plus and Cl minus cannot form, sir.
SCL and Cl minus 100% will form.
Sir, then covalent bond, no, sir.
Yes. You have to listen them, covalent bond and their properties. Am I told about the covalent compound properties?
No, sir.
Then you can understand. HCl is a covalent molecule. When they dissolve in water, what happened? Am I told about that? Mister? That is the next property. Na? We will discuss in the after
No,
the
sir.
covalent compound and their properties. If they come, we will discuss them. Okay, na? Now I am discussing about Lewis dot
Yes, sir.
symbol or Lewis dot formula. Okay. Lewis dot formulas with the different examples. First, for example, if I apply Lewis dot symbol for the group, okay, for number of valency electrons, okay, number of valency electron and example, okay, example. First group I am taking number of valency electron and Lewis dot structure. Lewis dot structure. Okay. First one valence electron, that is called first A. Example, I am taking hydrogen. Generally hydrogen, one valence electron. OR, you take lithium, one valence electron. OR, sodium, one valence electron. You take a second group. Best example, magnesium. How many valence electron? 2. You are showing as 2. That means the valency electron of the atom we are representing as either dots or cross mark. You call it as a Lewis dot symbols. You go for third group, third A, having 3 valence electron. Example, boron or aluminium, anything. You take boron, 1, 2, 3. 3 valence electrons. Now you go for fourth A group. What is the valence electron? 4. Example, carbon, silicon. Carbon, 1, 2, 3, 4 valence electron. Silicon, 1, 2, 3, 4 valence electron. Now you go for fifth A group element, that is nitrogen, phosphorus, etc. How many valence electron? 5. That is 1, 2, 3, 4, 5. You go for the next one, sixth group element, oxygen, sulfur, etc. Sixth group, that is oxygen, 1, 2, 3, 4, 5, 6. Sulfur, 1, 2, 3, 4, 5, 6. Now you go for seventh group elements. Seventh group, that is fluorine, like that. Fluorine, chlorine, bromine. Fluorine, 7 electron, 1, 2, 3, 4, 5, 6, 7. That means they can show as a paired or unpaired, no problem. Zero group, that is weighted valence electron, 8. That is helium, neon, etc. For example, helium you take. That is helium not there. Okay. Neon. Neon is how many? 1, 2, 3, 4, 5, 6, 7, 8, except hydrogen, helium. Helium has 2 electrons. That is the valency shell. So this valency electron or Lewis dot symbol, for example, I am given X, whose valence I am showing like this. What is the information you can recognize? Recognize group of the element. Group of the element. How to recognize? Yes, by looking at that, there are 3 valence electron. Therefore, it is a third A group element. Valency electrons is equal to 3. So therefore, Lewis dot symbol of an element, of an atom of the element, Lewis dot symbol of an atom of the element indicates group var are valency electrons in it. Is it right? Understood what is the use of a Lewis dot symbol of an element, which recognizes symbol of the, what is that, group and valency electron in it. If valence electrons are 5, 5th group, 6, 6th group, that is only for main group element. It is applicable for main group element. Okay. Now you go for the next. What is that? Some molecules if you apply. Okay. Lewis dot structure for the molecules and ions. Lewis dot structures for molecules and ions. Molecules and ions if I apply. Already I have explained some rule. Have you remembered or not? I don't know. For your convenience, one more time I will explain. First calculate N1. What is N1? What is N1? Yes, N1 is the number of, okay, valency electron present. N2, number of valency electron to be present if it satisfies octet configuration. Number 3, number of bond pair electrons. A is equal to N3 by 2, number of bond pairs. N4, number of lone pair electrons and which are not participating in bonding. That is N4 by 2. That is lone pairs. Lone pair of electron is N4. Lone pairs are NY4 by 2. These are the points you calculated previously. Am I told are like this? Okay. How to calculate this? N2 value. Number of hydrogens into 2. Number of other atoms into 8. Okay. Now, best example, H2 molecule you take. Okay, na? H2 molecule you take. Anybody having the doubts? Okay. H2 molecule if you consider N1, number of valence electron. Each hydrogen has 1 electron. That is why 2 electrons only. N2, number of hydrogens 2 into 2 plus number of other atoms 0 into 8 is equal to 4 electrons. N3, number of bond pair electrons. That is N12 minus N1. That is 4 minus 2. That is equal to 2 electron. You call this as a bond pair electrons. Okay. From this you can write bond pairs also. Bond pairs is equal to N3 by 2. That is equal to 2 by 2 is equal to 1. Bond pairs are 1. N4, what I said, N1 minus N3. N1, 2. N3, 2. That is equal to 0. That is lone pair electrons are 0 and lone pairs also be 0. Now you come to hydrogen. Okay, na? You come here for hydrogen. Hydrogen. How many bond pair electrons are there? 2 bond pair electron or 1 bond pair is there. Now arrange the bond pair electron first as a single bond. If still bond pairs are there, you place them as a double bond or triple bond. And if not satisfies the rule, arrange the lone pair as a octet rule. This is the point we learned on Saturday. Now check what is the condition. Note each atom should get, okay, each atom should get octet configuration. Octet configuration except hydrogen. Except hydrogen. Hydrogen has duplet configuration. Yes, it has. Now duplet configuration. No lone pairs. No lone pair. Duplet configuration. Duplet configuration. Molecule is stable. Over. Now you go for one more molecule. Let us take oxygen. Okay. Let us take oxygen. Okay. What is oxygen? N1 is equal to number of valence electron. Each one having 6 valence electron. 2 6 are 12 valence electron. Actually present. To be present. Number of valence electron to be present to satisfy octet configuration. 2 into 8 plus number of hydrogen 0 into 2. That is equal to 16 electron. N3 is equal to N1 minus N2. Sorry, N2 minus N1. That is 16 minus 12. That is equal to 4 electrons. So 4 electrons should be present as a bond pairs. That is bond pair electrons. Number 4. What is that? N1 minus N3. N1 12, N3 4. That is 8 electrons should be present as lone pair electrons. Now you come here. Oxygen and another oxygen. Okay. Number of bond pair electrons are 4. First one bond pair, two electrons are over. Not satisfied. Still one more bond pair is there. That's why 2 bond pair electrons are over. Now each oxygen has 4 electrons only. Not satisfied octet. Now you go for 8 electrons. 8 lone pairs are there. So 2, 2. Okay. If I place 4 lone pair electron here, it satisfied octet configuration. That's why I don't want to place one more lone pair here. Now if I place 2 more lone pair here, it satisfies octet. So satisfied octet and satisfied octet. Therefore, all 8 electrons are placed properly. Okay. So octet, octet. So bond pair electrons 4 and lone pair electrons 1, 2, 3, 4, 5, 6, 7, 8. I think understood. Okay. If not satisfied, I'll go for the next molecule. O3, ozone. O3 is called ozone. Now you write the ozone molecule. N1 is equal to N1, 3 oxygen. Each gain 6 electron valence electron. So 18 valency electrons. N2, what I said N2? N2 is nothing but if the valency electron present as octet, 3 8s are 24 electrons. It is actually present. This is to be present. Understood the molecule pointer. Now N3 is equal to N2 minus N1. That is 24 minus 18. That is equal to 6 electron. This present as a bond pair electron. Then bond pairs is equal to 6 by 2. That is equal to 3 bond pairs. Now you come to the next. What is that? N4. N4 is equal to N1 minus N3. N1 is equal to 18. N3 is equal to 6. That is 12. 12 electrons are present as a lone pairs. Our lone pairs is equal to 12 by 2. That is equal to 6. Now you come to oxygen. Come to oxygen. I placed one oxygen here. I have placed one oxygen here. I have placed. And 3 oxygens are there. One oxygen I have taken central one. Remaining 2 are attached one. No other chance. Sir, some students are getting doubt. Sir, why don't you write like this? So these can be known from further theories. Sir, why do you write angularly? Why don't you write linearly? Yes, they first tried with linearly only. But later they identified that they are not linear, they are angular. Okay, na? That will be known from further theories. For further theories. Okay, now how many bond pairs are there? 3. First bond pair, second bond pair. First bond pair, second bond pair. Already I told you, first bond pair you place as a single bond. Now still there is a one bond pair. That's why I placed it as a multiple bond. Now, after placing the bond pairs, 3 bond pair, 1 bond pair, 2nd bond pair, 3rd bond pair, no atom gets octet configuration. Now I will use lone pairs. How many lone pair you have? 6 lone pair. 1 lone pair if I use here. Yes, if I use 1 lone pair here, my oxygen get octet configuration. Yes, my oxygen get octet configuration. So still there are 5 lone pairs. Yes, if I use 2 lone pairs here, yes, it gets octet configuration. Okay, still there are 3 lone pairs. 3 more lone pairs. Yes, if I use here, yes, now this oxygen got octet. So this got octet configuration, this got octet configuration, this is also got octet configuration. All of them have octet electronic configuration. Now, if I write the molecule, here O and O, 2 lone pairs, 2 lone pair, 2 lone pair, 2 lone pair. Here is a bond. 2 bonds are there. Yes or no? Now, if I write this one, okay, oxygen here, oxygen here, oxygen here. 2 bonds, 1 bond, 1 lone pair, 2 lone pairs, 3 lone pairs. Sir, here one of them, nothing is not given. Already it has 6 electrons, 6 is remained as lone pair, and it taken the electron, that's why negative. It has given the electron, that's why positive. Understood? So it gets negative, it gets positive. Now some students are getting doubt. Sir, why do you give lone pair here? You give 2 dots, sir. Some students are getting doubt. Sir, I want to put double bond here. I want to put single bond here. Yes, you can put like this also. No problem. Yes, you put like this also. Sir, because of no electron was given, that's why negative here, that's why positive here. Now that means in the 2 structure it can be existed. Both are equivalent. Both are equal. Both are equal. Any one of them is correct. Okay, na? I think anybody having the doubts? Anybody having the doubts on it? I think no one. Yes. One more. Only wait. Okay. Who is having the doubt? Akash Kumar.
Sir, how you mark the sign, sir?
How the mark the
Sign.
sign?
On-
Na?
Yes,
Okay,
sir.
next I will tell you. Next, Snehita Reddy.
So the one bond is in sir, between one oxygen and another oxygen.
Ah.
Is that coordinate covalent bond?
Yes. That is the reason why I put plus and minus, but I should not explain that is a coordinating covalent bond now. Okay, na?
Okay,
Yes,
sir.
you are right. Divit Reddy, what is your doubt?
The same dots are signs.
Yes, actually this oxygen given lone pair, but does not given. That's why it is a coordinating covalent bond.
Sir,
It
how
is
do
a
I
coordinating
enter, sir?
covalent bond. If you don't want to write plus and minus, simply write like this. Instead of plus and minus, you put like this. And what is the meaning? This oxygen given lone pair, so this the oxygen given total electron pair, but it does not give anything, but shares. That is why it is coordinating covalent bond. That's why it is coordinating covalent bond. Okay, na, mister?
Okay,
I
sir.
think everybody's doubt. Instead of positive, negative, it was taken. That's why positive, that's why negative I have shown. I think first student doubt also cleared. Okay, now these are called ozone. Now, okay, students, wait for 1 minute. ఇప్పటికే చాలా క్రెడిట్ కార్డులు ఉన్నారు నాయన ఇంకేం చేసుకోను. Now you go for CO3 minus 2. Am I completed CO3 minus 2 previously? Am I completed CO3 minus 2? Tejas Naidu. Yes, Pritam.
Yes, sir, you have done, sir. Not bonding, sir, but you have explained this N1, N2 and all, sir.
CO3 minus 2 is over.
Yes, sir.
Okay, I'll go for NH4 plus. Now I'll go for NH4 plus. What is the NH4 plus saying? What is the NH4 plus saying? N1 is equal to, how many valence electrons are there? Nitrogen 5. What is the nitrogen having? 1. Plus charge. Whenever plus charge is there, remove electrons. How many? Plus 1. That is why 5 4s are 8 minus 1. 5 plus 4, 9, 9 minus 1. 8 electron. Sir, positive charge, remove electron. Negative charge, add electron. How much positive? 1. Next, N2. If nitrogen is present, 1 into 8 plus hydrogen, 4 into 1. That is 8 plus 4, 12. Okay. Next, N3, N2 minus N1, 12 minus 8, 4 electron. So 4 electrons is a yes or no? Am I getting it wrong? 12 minus 8, 4. What is that? 1 into 8 plus 4 into 2. Oh, mistake here. That is why I'm getting wrong. Yes. 4 into 2. 4 2s are 8 plus 8, 16. 16 minus 8. That is 8 electron. That present as a lone pair electron. Sorry, bond pair electron. Now bond pairs is equal to 8 by 2. That is 4 bond pairs. Now you come down. Now you go for N4. What I said N4? N3 is equal to 8. 8 minus 8. 0 lone pair electron. Yes. Now you come here. Who is the least repeating? Nitrogen. Arrange 4 hydrogens. Sir, why don't you arrange what is that in a square, sir? I don't know the structure now. That is the drawback of Lewis octet rule. Lewis octet rule does not explain the what is the strength, does not explain the structure, just explain the stability of the molecule by octet. Yes. How many bond pairs? 4. 8 electron bond pairs. 1 bond pair, second bond pair, third bond pair, fourth bond pair. Now, because of this, my hydrogen got 2 electron, my hydrogen got 2 electron, my hydrogen got 2 electron, 2 electron. Each hydrogen has a duplet configuration. Yes, hydrogen duplet configuration is stable, but nitrogen got octet configuration. Therefore, the molecule. Sir, where is the positive charge? Yes. NH3 plus. Now, actually, what is that? One of the bond is actually coordinative covalent bond. But I can't show coordinative covalent bond here. Yes. Okay. This is the way we can represent the NH4 plus. I thought everybody understood. Okay. Now you go for HNO3. If you want, I will explain HNO3 also. HNO3. Okay. HNO3. What is the N1? Hydrogen 1 electron is present. Nitrogen 5 valence electron is present. 3 into oxygen 6. 3 6 are 18 plus 5. 18 plus 6. What is that now? 24 electron. If you write as what is that octet configuration? 2 into 1. Atoms are 1 each 2. 4 is there. 4 into plus 2, 34 electrons. So N1, which is equal to 34 minus 24, that is equal to 10 electron is present as a bond pairs. Then bond pairs is equal to 10 by 2 is equal to 5. Now you go for the next. You go for that N5. Sorry, N4. That is N1 minus N3. N1 is equal to 24. N3 is equal to, what is that? 10. That is equal to 14 electron is present as lone pair electrons. Is lone pair is equal to, what is that? 14 by 2 is equal to 7. Now, who is the central atom? Last, already I told you, other than hydrogen, less electronegative, nitrogen. That is why other than hydrogen, less electronegative, nitrogen have taken central atom. oxygen. Okay, some students are getting around the nitrogen. If I place like this, okay. For some students' convenience, I am writing like this first in a drawback way. First, I am writing like this. Okay. First, I am writing like this. How many bond pairs are there? 5 bond pairs. Yes. 1 bond pair, 2 bond pair, 3 bond pair, 4 bond pair. Yes or no? 3 bond pair, 4 bond pair. One more bond pair. If I write like this, nitrogen 1, 2, 3, 4, 5. 5 2s are 10 electron. Is it possible nitrogen 10 electron around that? Wrong. Is it correct or not? Wrong structure or not? That is why I don't want to write like that. That is why I am placing like this. H. Anybody having the doubt on this? Okay. What is your doubt? Funny.
Sir, due to internet problem, I couldn't hear how NH4 had a plus, sir.
How NH4 add plus charge? I don't understand.
Sir,
NH4 plus is already present. For existed molecule, I am writing the structure.
No, sir. In that NH4 plus, how does the molecule has plus charge, sir?
That is only I am saying, Nana. For the existed molecule, I am providing the structure.
Okay, sir.
I am not creating the structure. NH4 plus is there. How it is there, we will discuss after covalent bond completion. Okay?
Yes, sir.
NH4 plus, how it is there, I will discuss. But I am explaining NH4 plus structure now.
Okay, sir.
I am not creating plus now. Understood? Snehita Reddy, what is your doubt?
Sir,
Sir. Your voice is beeping. Okay. Sir, some student just now asked one question. Sir, how the... I think my internet problem. Okay. Some student, so just now one student asked me, sir, existed NH4 plus molecule, I am explaining. How do this NH4 plus formed? How do that NH4 plus formed? Okay, we will discuss this point after the covalent component, coordinative covalent component plus was formed. But now I am explaining only structure of our Lewis dot structure of NH4 plus. Why do that exist? 1, 2, 3, 4. 4 2s are 8 electron is existed. That is why I can explain. Okay, na? Okay, some student have sent to me one doubt.
okay.
Okay. Your voice is tracking, sir. Now are you getting Miss Snehita Reddy? Who is that? Sai Vignesh. Sai Vignesh.
Now it is clear, sir.
Okay, na? And sometimes
sir.
up and down of fluctuation of internet. Okay, na?
Okay, sir.
Now, so student, okay, then I am explaining NH4 plus already existed. I am explaining the structure. Now, likely HNO3 also existed. So, 1 or 2 members, you please be unmute only. Okay, Sai Vignesh already were unmute now. Okay, we please unmute. One of you, please. Okay, wait. Akshita, Akshay Kumar, okay. Akash Kumar, you please unmute. Okay, you please be in unmute because I will ask you whenever the problem arises, you please tell me. Okay?
Okay, sir.
Next, you come here, all of you. Sir, if I given the structure like this, oxygen, nitrogen. Nitrogen has 5 bonds. 1, 2, 3, 4, 5. Nitrogen never exceeds its covalency by 4. Nitrogen never exceeds its covalency by 4. More than 4 is not possible. But if I given like this, it has 5. That is why it is wrong. Now that is why I'm going like this. Now I'm placing the lone pairs. Bond pairs. How many bond pair? 5. Okay. 1 bond pair, 2 bond pair, 3 bond pair, 4 bond pair, and for my convenience, 5th bond pair. What I told you, first you give first bond pair as a single bond. If any extra bond pairs are there, you keep as a multiple bond. Yes, one more extra is there, I kept as a multiple bond. Now bond pairs are over. After bond pairs over, you please observe the logic. My nitrogen got my nitrogen got octet configuration. My hydrogen got duplet configuration. No extra electron required. Who required? Yes, oxygen has just 2. To get the stability, how many lone pairs are required? 1, 2, 3, 4, 5, 6. And that is 6 lone pair electrons I placed. Here how many required? 4. 1, 2, 3, 4. Yes, 4 lone pair I placed. Here required 4 again. 1, 2, 3, 4. Now if you observe that total number of lone pairs 1, 2, 3, 4, 5, 6, 7 is over. Number of bond pairs 1, 2, 3, 4, 5 is over. So now you please observe the logic. Molecule become N double bond O, N O, N O, H. Here 2 lone pairs I placed. Here 2 lone pairs I placed. Here no lone pair. Here 3 lone pairs. 3 lone pairs of oxygen still they present. And what is the meaning? No electron was given by this oxygen. And there must be coordinated covalent bond. I think understood? Okay. So this is the way I can propose the structure for HNO3. This is the way I can propose the structure for HNO3. I think everybody understood my point. Okay. HNO3 structure. Otherwise, instead of that, you can show like this also. How, sir? N double bond O H S lone pairs, 3 lone pairs, 2 lone pairs, 2 lone pairs, and here is negative you put, here is positive you put. Otherwise, either like this or like this. Instead of coordinate covalent bond. Now you go for the next molecule, student. What is that? Yes. If you apply my rules, N1 is equal to other than hydrogen is only, that is beryllium valence electron 2, fluorine 2 into 7, 2 7s are 14 plus 2, 16.
Hello.
Electron.
Sir, your
N2
voice is
than
breaking.
hydrogens are 0. Okay, now is it clear?
Yes, sir, now clear.
So 8 3s are 24 electrons. Now N3 is equal to N2 minus N1, 24 minus 16, 8 electrons. They present as a bond pair electrons. 8 electron as present as a bond pair electrons. N4, that is N1 minus N3, 16 minus 8, that is 8 electrons is present as a lone pair electrons. Okay. Now you apply the logic. Beryllium, fluorine. Beryllium is the least repeating. That is why I write and written as a central atom. How many bond pair electrons? 4, 8. And the bond pairs are 4. Lone pairs are 4. Bond pairs 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So my beryllium gets what is that? Satisfied. Fluorine. How many lone pairs still required? 1, 2, 3, 4. 1, 2, 3, 4. And what is the meaning? What is the meaning? This fluorine was given. What is the beryllium valence electron? Generally, beryllium valence electrons are 2 only. But Here 3, here 3. Is it possible for fluorine to give 3 electrons? That is why absolutely it is a wrong structure. And according to this point, beryllium, fluorine, double bond. Is it possible? And a fluorine given, what is that? 3 electron, positive charge. Fluorine given 3 electron, positive charge. Is it possible like this? 100% not possible. Yes or no? That is why even though they satisfied the octet configuration, the given structure is a wrong one. But do you know BF2? What is rule? This is the best example for violation of octet rule, sir. That is why I should not apply my concept, whatever so far covered. If I cover like this, fluorine gets highly positive and 2 double bonds. Yes, sir. 2 bonds they are getting. How? Once again explain. How lone pair donated to oxygen HNO3? How lone pair donated, Nana? You got what is that? 3 lone pair on oxygen. Oxygen valence electrons are 6. They still present as 6. And the oxygen does not give anything. So nitrogen gives this lone pair and both shares. That is why it is called coordinative covalent bond. Now you come here in this example. Now in this example, what you are facing the problem? If the fluorine gives 3 electron, it is highly impossible. That is why the structure is wrong. That means that sometimes whenever they violates the structure, you can't apply this rule. So beryllium given 1 electron, beryllium has 2 valence electrons only. Fluorine has 7 valence electron. Yes. Now fluorine gets octet configuration, but beryllium does not. That is lack of octet. Even though molecule was existed, and this means that is what is that? Violates octet rule. What is octet rule saying? Those molecules only existed in which each atom. What is octet rule? Those molecules only existed in which each atom should get 8 electron. Even though there is no 8 electron, my beryllium was BF2 is present. That is the best explanation. That is best example violating the octet rule. Now you go for BF3 molecule. Now you do for BF4 molecule. Do that tomorrow. BF3 molecule, BF4. If possible, you write this BF4 minus 2. Okay, no need. This is complex for you. No. You do this. BF3 and BF4 molecule tomorrow you try. Along with what is that, Nana? Water molecule. Along with ammonia molecule. Along with what is that? P4 molecule. Along with S8 molecule. Tomorrow you practice for all these examples once. Okay na, P4, S8, ammonia. Okay na, and next one more example, you practice that CH4. Okay, you practice all of them. Tomorrow you should show to me. And N2. Okay, this molecule you practice. Along with this, tomorrow I will see. You practice that. Tomorrow we will continue the remaining part. Okay, thank you. Bye. Once if I stop, all of them become 116. Suddenly I saw 134 before 5 minutes. Now it is 116. Bye.